Okay, welcome to the cast of thousands here that gather around our Itelco bi-monthly webinar. Today we will be continuing along the same lines with the previous ones we've done in this Itelco series of television broadcast equipment. Today we will be doing a seminar on talking about our low and medium power transmitters, including gap fillers and exciters. And joining us today, you can see on camera, we have Alberto Milani. Say hello, Alberto.
Hello to everybody. Thanks for thanks to stay with us in this section, webinar section. Thank you, Frank. Good morning. Good afternoon for you.
Good afternoon, good morning, and if anybody's listening from North America or South America, I guess it would be early morning. But in any event, here we are. I'm located in Chonburi, Thailand, and which is very close to Bangkok. And as most of you know, I am the Asia Pacific Sales Manager for the Elenos Group, which includes Elenos, Broadcast Electronics, Itelco, and also Pro Television. So today's presentation will focus mainly on Itelco and Pro Television, with Elenos FM not really being covered today. So with that, let me get started with today's presentation. And again, thank you for everyone to come. Today, our group now with the new logo for the Elenos Group includes the 4 companies that I mentioned. It's all came together before the end of the year last year, and the history of our group is quite lively with 2 companies in Italy, starting in Itelco in 1962 and Elenos 1977. It goes back there, and BE 1959. So we're talking about major companies in the broadcast industry in both in AM, FM, and television for the better part of half of the prior century and into the 20 years here in 2000. So that's not even to mention Pro Television and our esteemed colleagues located in Denmark that have formerly been with Philips TV and Test Equipment Group, had a major part in say and design of a lot of the standards that we see today that go into DVB-T2, ISDB-T, anything digital in the TV world and also in the FM world. We're also working with Pro Television to provide for us a lot of the audio modulation as well. And in that case, all our products are both analog and convertible to digital, or digital convertible back, which doesn't happen that much. So let me move on here a little bit. And well, the combination of these 4 big groups, giants, bring about 90 years of experience, and I think most of the group that attends to us as customers or as partners and distributors and sales agents, so are really familiar with our company. So worldwide, this number keeps growing, and I've kept it the same for the last 4 months, but 60,000 installations at least. And you can see a list of centers of excellence that we have in our Asia Pacific group. We really have to talk highly of BTSI that's located in the Philippines, and VTech in Taiwan, and we have in India Technomedia, and you know, several others. And I just have to say we're blessed and fortunate to have so strong groups that are able to do the whole process from the microphones to the antennas and everything in between, and on the TV side, handle a lot of the studios and also for radio as well. So so our centers of excellence allow us to be able to push our support out into the territories. For example, in the case of Shanghai Yi Hui Nuo Broadcast, they can basically do repairs locally, and they can do installations, and they can do, pretty much anything that we can do in Italy. The same is true for BTSI in the Philippines. So with that, let me talk a little bit about some of our customers in Asia, which this is by all means very centered around our market in the Philippines, which is really big and exciting. But in addition to the Philippines, I think most of you know we have a Radio Maria based out of Italy. That's a big part of our business in Asia, and several other companies from Itelco. And we have some very, very large TV transmitters in Vietnam, Thailand, Sri Lanka, and also in Indonesia that go up to 60 or 120 kilowatts. So, so the company has seen a lot of growth in the industry and taken it through up till today. And hopefully we've made some big growth in areas of low and medium power, because we see a lot of the business sort of moving away from the high power, one volcano town, big tower type transmitting, where today with a lot of the digital technology, we see a combination of higher power transmitters in the capital cities or provincial giants, and then a lot of smaller transmitters into the provinces, and a lot of gap fillers, of course, being used. So we'll be talking about how we do that with lower power and with gap fillers and things like that today. So Alberto will deal with the technical aspect of it. The first part, which we had covered weeks back, and we'll kind of go back into this today, combination of our MEX II TV exciter, which is multimode analog and digital. And you can see it goes into what we call the IEC 100 transmitter, which is a smaller power transmitter. Believe me or believe it, 100 watts digital can still carry some decent distance. So same hardware, different firmware and software loads. We get DVB-T2, T, ISDBT, ATSC, ATSC3, and even in Asia, with our Korean friends, some of which may be here today also listening, we're seeing a jump from the ATSC standard into ATSC3, which is what's used in the US, but a little bit different recipe. Also DAB, which we haven't seen quite the transformation as we've seen in Europe, but we see a little bit of it in Asia. DMB mainly being some major work being done in DMB in Korea today. So these are low power exciters, standalone transmitters, MEX II, 1 watt up to 25 watts with a power amplifier in the IEC 100 series up to 100 watts RMS. So that's the first step into the transmitting. It looks like this, 1 RU. Again, both in multimode analog and digital. So the new design is incorporates the latest and the greatest modulator technology that we get out of Pro Television. So we've been working with Pro Television for several years, but sure enough, everything that you're seeing here today has the latest technology, and it's moving fast. The technology is moving fast. Okay, so now we have the MEX II, a little bit more in detail about the MEX II 10 watt 1 watt, 10 watt, or 25 watt. Now this is a low power exciter or a gap filler. So, you look at it and you could practically say, hey, is that a gap filler or exciter? It's both. So we'll have a schematic that explains a little bit more about it. If we look at the front view, you can see the normal things that most of our transmitters usually carry. Open ventilation front to back, a series of controls to be able to use the screen here in front of the unit. The neat thing about this exciter is that this theme and everything here carries from everything up to the high power units in the Northia and Thamla transmitters as well. So, once you deploy anything from 1 watt all the way up to 120 kilowatts, for example, you'd be looking at the same screens and the same technology and so forth. So, except for, additional features when we have multiple PA type systems. So Alberto will touch a little bit on some of the screenshots in a little bit. Okay, so on this schematic, we can see the main difference here for the here is we have a receiving section that also has the possibility of an optional satellite input. And in addition, the technology that we use for the new gap fillers that we deploy now and that become part of our product offerings are in this receiver section. So you see this modulator and this receiver working very close together. Additionally, you can see that, for the low power type system, and let me move on in this and I'll have Alberto go into a little bit more detail in one of the other models here right now. But this, for the most part, is a standard architecture for the various models that we'll talk about. Alberto, do you want to say anything more before we move on, or do you want to address this when we get to maybe the IEC 100 or some of the other models?
You did a perfect introduction to the perfect introduction about the systems. You can go ahead with the next slide, and we can come a little bit in the depth of the technology after these few slides that are representing the low power transmitters. So basically, as you say, we have these two line MEX and the IEC 100 that represent a small power size transmitter that can be, thanks to the fact that at first that they are in multi-mode technology, so capable to meet all the standard for the analog or digital transmission, only by changing of the firmware inside to the hardware. We have this opportunity. More than these, you show the top view of the MEX and the top view of the IEC 100, that is the medium power transmitter, the low power transmitter, are exactly same with the same features, and they are composed, except for the power supply and the final power amplifier stages, they are composed by the same boards. So this is an advantage for the field engineers that they are called to make the installation and the service of these devices. Can you come to the next slide? Sorry. Next, perfect.
So as we see the front panel for the IEC 100, it's very similar to the other, except as Alberto mentioned, we have the difference being with the power supplies and also the final amplifier stages. So now we're into 2 RUs as opposed to 1 RU. Okay. Perfect. And okay, why don't I get you to discuss this? Let's go into the detail about this transmitter because it has everything that the MEX II has in it, but with in addition the the amplifier stage is 400 watts.
Perfect.
Yeah, it's for you
So,
now.
but this unit basically has it's a multi-standard transmitter, analog or digital or both. So this means that it can change from the analog modulation to the digital modulation just in a click. And it has an option that is the satellite receiver board with the CAM descrambler. So you have the possibility to build inside to only 2 units, the receiver, the satellite receiver, and consequently the transmitter. The output of the board, it will be in ASI, and then you can come inside to the digital modulator. With this configuration, you do not need any additional equipment. Basically, the transmitter is using the latest technology available on the market, include this high reliable and performable digital modulator board. We have the possibility we will see this in the details later on, we have the possibility to build inside directly the GPS receiver, so consequently GPS allowed the using of the transmitters as small transmitters in SFM mode as well. Please, Frank, next. Perfect. So this is the configuration that we will go to introduce you, to show you, and we are talking about MEX and IEC 100. We have also IEC 200, that is another step up of small transmitter that is not shown in this short and brief introduction. So these units can be used as exciter to drive high power stage amplifiers transmitters. They can be used as a standalone transmitter, as transposer, or as a gap filler, according to the configuration of the board that the customer required to be located inside. So in the MEX II, one uniguy, except the RF output filter that today becomes big and they are external, we have the version of 110 and 25 watts RMS. For the IEC 100, we have available the 100 watts RMS. As we say, multimode, so means same hardware with different firmware to generate analog transmission or T2 ISDBT, APSC, APSC 3.0, DAB, and DAB and DAB. Next, please. So the configuration in this case is as a gap filler. So what means gap filler? Gap filler, this means that instead to come inside for the transmission, to come inside the unit, to the transmitting unit with ASI or IP stream, we come inside with the RF received by a receiving antenna from an high power transmitter that it can be located far away from this unit. In this case, there are advantages and disadvantages for this technology, but we have this unit that is cheaper than the other one as installation and so on, because they do not need the radio link. In this case, we have an additional board. Can you move to the next, please? Perfect. Instead to have the satellite receiver board, we have a front end that basically, we will see in the details, the block diagram also later on, that allowed the inputs of the radio frequency channel. And in the details, we can receive any band, because the most important thing is that the bandwidth of the signal will be the same, but in this configuration we can receive, for instance, the VHF or the VHF first band or VHF third band or UHF, and you can transmit it in VHF or with a different model UHF band through this receiving board. These provide the advantage to do not need additional radio links to move the signal the ASI or IP stream. Next, please. Perfect. The same configuration as we mentioned for the transmitter is available for the gap filler for 100 watts. A lot of people maybe is asking about why 100 watts and not 200 or 400. But this is one of the details that we will check in topics later on, because to use the gap filler is very important and mandatory to be capable to create an extremely high isolation between the receiving and the transmitting antennas. Please, the next time. Frank, next. Perfect. So as you can see, the configuration in the 100 watts is exactly the same, except for the power amplifier that is bigger and the power supply that it must be bigger too in order to provide the enough power to supply the radio frequency final amplifier stages. Next, please. Perfect. This is one of the main and important part of our digital modulator. We will come in the topic details later on as well, but we have one of the most intuitive and friendly user web graphical interface available on the market. Our PTV colleagues makes really an excellent job. So basically, all the managing of the transmitter is made by through this drag and drop technology, and moreover, we have the big advantage to grant to the customer one of the best performable linear and non-linear on-time digital precorrection, automatic precorrection. Next, please. Perfect. What is basically the difference between transposer, translator, or gap filler? Basically, transposer or translator means that you can come inside with a signal and you can go outside with a different channel. So I am coming inside with channel 23 and outside with a different channel. So basically, input and output channel are different. In some case, we need to have an additional input bandpass filter. The output is always needed, and basically we can change the channel. In the case that, next please. So with the transposer or translator, A and B channel is the same. Is the most convenient and practical method to filling gaps, but you need a new channel available. This is the disadvantage. Is the easier solution because you do not need isolation between RX and X antenna. You do not need synchronization. You do not need any echo cancelling. Moreover, is easy installation, less interferences planning, and best signal to noise ratio ensures. But if we do not have another channel available and we are using a already scheduled and planned and realized SFN network, we can see the next page and we will see the solution of the so-named gap filler or on-frequency repeater. Basically, these units are working inside to an SFN network, single frequency network operation mode. In this case, the input and the output signal are the same. And in this case, also to protect from some interference signal, I need the input cavity filter. And in this case, we are using the same channel. Next, please. Perfect. Gap filler or on-frequency repeater in SFN. Gap filler or on-frequency repeater receive an A channel and retransmit it on the same frequency. This is generally used to optimize the spectrum frequency, allowing the growth of TV channels, to make a uniform the coverage and the distribution, increasing the system availability and reliability, and presence of multiple transmission points. Is mandatory condition to implement an SFN network, transmitter synchronization, same transmission frequency at the same time, but especially the same BTS or stream method that have not to be under any kind of rearrangement. So this means that once I met the transport stream or the BTS, I cannot change it, I cannot touch it anymore, I cannot add any additional channel by remultiplexing. Next, please. Okay, perfect. This is the.
Which one you want? This one or
this one?
Okay.
This one, perfect. Gap filler and or on-frequency repeater in SFN. Disadvantages: transmitted power is limited by the also if we have the echo. The quality of the transmission can be easily deteriorated by other transmitter. And we need, absolutely, it is mandatory, be able to create a high isolation transformers, high isolation between the transmitting and the receiving antenna. The advantage, it's easy installation and low cost. We do not need the GPS synchronization, so no additional antennas and so on. And it doesn't require any additional transmit network. Next, please. Okay, this is the gap filler repeater block diagram. As you can see on the left side, you have the radio frequency input, then you have a preamplifier, and you have the tuner. The tuner has a sense that is kept on the output of the transmitting line for the AC sense. AC sense is the echo cancelling. So basically, portion of the signal is kept and forward back to the tuner in order to create the echo cancelling effect. We will talk about this later. Then you have the modulator board, and the modulator board have two sense that are coming back. One is for the linear sense, for the linear automatic precorrection, on-time precorrection, and then before the filter you have the non-linear sense that is for the non-linear precorrection. So basically with the non-linear precorrection we will go to precorrect automatically is used to optimize the MER and Schulder's value. Instead, the linear precorrection is made in order to linearize the phase and the group delay. Next, please. Okay, concept of the echo canceller. Basically, the echo canceller is generated by the feedback, the back forwarding of the transmitted power to the receiving antenna. This is a concept that is very easy to be understood. But basically, why also we limit the output power? We limit the output power because if we go to consider the input level of these units are capable to accept also a level, a radio frequency level that is -77 dBm of input field. On the other side, if we use, for instance, the output that is 10 watts RMS, we are at +30 dBm. 10 watts is +40 dBm. So this means that the delta between 77 and plus 40, we are talking about 117 dB gain. So on this, without including the antenna gains, or on a so high gain, we need absolutely to create an extremely high isolation, because the effect of the echo concealer, so basically the effect that we will go to see in the next slide, the effect of the echo concealer, the correction can be between around 30 dB, no more. So we need to create isolation, and after that we will see why. So echo delay, the delay between the echo and the received signal. Echo windows is the length of the echo channel impulse response. Process delay, the delay of the echo cancelling process, and these windows can be shifted and moved between 7 and 14 microseconds in order to create a feedback that it will go to make the whole to reduce the echo effects. So next, please. Perfect. For this reason, we need more than the echo cancelling that is available and can give us an end in order to increase the quality, the transmission quality, and to make the system capable to work. We have to create high isolation between the antenna transmitting and receiving one. In which way? For instance, we can do it creating mechanical protection. So basically, the transmitting antenna has a position on the left, and the receiving antenna covered by buildings or something like this on the opposite side of the small mountain, of the pitch of a mountain, in order to create isolation between the antennas. So the two antennas, transmitting and receiving one, cannot be closed. So SFN, we can talk a little bit about the SFN system. So basically, SFN network allowed continuous coverage from the transmitter area to another, and makes more efficient use the use of the spectrum. SFN requires careful coverage plan and detailed and precise timing. For digital TV and DAB, a guard interval is used, but it is not possible for the analog. In fact, this is one of the advantages of the digital transmission. Digital transmission allowed the use of the complete spectrum. So basically, you do not need channel in between channel guards, but you can transmit in adjacent and co-adjacent channels mode. Then this means that analog SFN network have to be carefully scheduled and organized. Next, please. Okay, this is a simple example for an SFN structure. So basically, on the left, you see the SFN adapter. So basically, this unit will stamp inside to the transport stream that is coming from the head end. It is stamping the time and frequency references. After that, this signal, this mapped transport stream, can be distributed through different ways. So transparent radio links. So this means that the radio links have to be, for instance, with QAM modulation, not this through COFDM modulation. You can move the signal, you can transfer the signal through satellite, or you can transfer the signal through optical fibers. Once there is a mapped transport stream will arrive to the transmitting site, it will come inside to the digital modulator. The digital modulator is equipped, of course, with the GPS receiver providing time and frequency references. And in this case, the digital modulator will be capable to calculate the transit time, the transit delay of the transport stream from the mapping side up to the transmitting side. In this way, you are able to insert automatically the network delay. So in this time, you have a perfect configuration. This is a simple example about the mapping transport stream made by the MIT inserter, where you will go to stamp inside to the system the 10 mega and the 1 PPS references. So basically, the 10 mega is the frequency reference, and the 1 PPS is the time reference. Once this transport stream is mapped, if you want that your SFN network works properly, you do not have to remap in any case the transport stream again. Please, next. Okay, these are some of the characteristics of our gap fillers parameters. So we have an excellent protection due to the inside digital filter. We have an excellent sensitivity thanks to the level that can accept up to -77 dB. And we have an excellent noise figure that is at least maximum 8 dB, but generally typically 6.5. Of course, we have also the excellent output performances about the MER. Next, please. Perfect. Of course, in our configuration, we can also talk about complete transmission system. What I mean that the transmission systems may be configuration in 1+1 or n+1, talking about small power transmitter, or also talking about repeaters or gap fillers. So an excellent logic unit is capable to manage all the system in order to provide the best operation mode. Next, please.
And as we were talking before, the interesting thing about this is, as you see the different products in this range, from the MEX exciter through to the low power transmitters, you would see similar type arrangements if you were doing the N+1 with our Thalna air-cooled medium power range up to about 3 to 5 kilowatts, and then furthermore in the liquid-cooled Northia product line. So here we go with a 3+1 configuration, and Alberto, take it from here. Which I should mention probably that not only in radio, but we've seen a big push towards transmission companies to do more systems like this, whether they're small output powers. We're seeing a lot of N+1 that could be, we'll just call it N+1, that N being up to, 2+1 up to 5, 6+1 configurations. We see a lot in FM today also too. So it's interesting, the co-location of sites and AC line conditioning equipment. We end up, when we do this, doing almost a custom solution for each of the sites and for our customers. So Alberto, why don't you dissect this a little bit further into some detail?
So I can come a little bit in detail. So this means that we have a standard equipment, so standard transmitter, small transmitter, or gap filler transposer configuration, and our logic and the supervised unit is capable to manage all the system, including the coaxial switches. At the input, we can have different configuration. We can have a configuration with the splitter, or as according to several government television networks required, also a coaxial switch at the input in order to be able to do not have an high insertion loss due to the splitter. Generally, with the splitter for 3 units, I can lose a lot of dB in the splitter, and I go to improve the noise figure. So some television networks doesn't like this, and they prefer to move in a different way with the input coaxial switch. So in any case, our logic unit is capable to manage also this, and basically we do not have any difference, any difference between the standalone transmitter and the transmitter used in n+1 configuration, this or 1+1. So this means that in the event that I want to use the single unit as a standalone, I can keep the unit out and I can do it. Okay, next, so we can talk a little bit the digital modulator. So basically here, as we say, we have available 1+1 and n+1 configuration for all the units. Next, please. So we talk shortly about this component of our group that is extremely important and make us capable to do a lot of things and make our customers capable to manage in a very friendly mode the digital modulator and the digital transmitter. That is pro television. Please, next. As we say, and as we told before, we have different modulation available. Next, please. Then we have the possibility, especially for the SDBT technology, to have inside the remux that is often used, and especially this important thing, adaptive precorrection, linear and not linear in real time. Next, please. OptiPower is a kind of developed algorithm that is capable to increase the performances and the efficiencies of our amplifiers between 2 and up to 5%. Next, please. Okay, this is what we saw before about the drag and drop technology that is very comfortable so we can plug our PC on the RJ45 connectors and we can move everything through these intuitive and friendly user graphic interface. Next, please. Okay, as we say, we have a part of the input of the signal of the board that is an option, of course, but it's available, and is the ATV analog TV application modulation simulated, emulated by the digital modulator. Next, please. Okay, next again, sorry. Perfect. This is a simple block diagram where we have on the left side all the input for the digital modulator with information about the GPS receiver, and then finally the final amplifier stage. And so the information that the transmitter can be dual cast, means we can transmit analog or we can change easily to digital. Next, please. This is the spectrum. Simply and shortly, the spectrum for the analog, where you can transmit in 6 or 7 megaband according to the standards around the world, only one program, video and sound, and instead on the right side, the packet where you have inside 7,000 carriers, and you can transmit basically several programs in only one transmitter and only one channel, UHF or VHF channel. These again on the left, the spectrum and the constellation. The constellation on the right, you can see on the 4 vectors where there is the representation of the 1 sec, so basically the television for the mobile application, and on the right one, the modulation for all the vectors for the layer B, where we have the television programs and the sound programs as well. Next, please. Perfect. Next again. Perfect. This is the drag and drop condition, where you can see in the middle we have the spectrum, the mask of the digital modulation, because the digital precorrection provide directly the feedback, and so without any spectrum analyzer or expensive system, you can check the operation, the proper operation of the transmitter at site only through your PC. Next, please. Okay, advantage and disadvantage, we already talked about this. Basically, in one condition, you are capable, with the digital, you are capable to have plurality of information, because you decrease the channel required by the transmission of the channel. You can operate in SFN mode, and you can save a lot of money also to joint the environment condition and the pollution condition, because you can transmit several channels in the same band with one transmitter instead of several. Next, please. Perfect. This is the example that we can use also DAB and DAB+, so digital audio broadcasting with the same board. Next again, please. Perfect. I pass the arguments to you, Frank.
Okay, well, very good. Thank you for the presentation, and you know, it's all laid out so that it's fairly simple to understand the basics of it. And we do plan at some point to do a more technical group of seminars on the multimode and also on gap fillers technology. So this will be coming up. And in addition, I believe the next seminar that we're going to do in 2 weeks will cover one of the very, very important areas for us as broadcasters in predicting coverage of antenna coverage and so forth. And it's you know, it's quite an art. There's not as many out there doing it. A lot of it used to be done by predictive mathematical equations and so forth. But now with Google Map and all that stuff, we're able to use some of the standard computation modules to do it in analog and digital, and look at interference, co-channel, adjacent channel interference. So hopefully we'll put together in development now a really nice seminar for you guys in 2 weeks that will deal with these arguments. Let's see, let me ask Alberto, is there anything else that you would like to mention before we go back to sleep for another 2 weeks, or what?
So
we never sleep, by the way. That's
now we will prepare. We are in phase of preparing this brief introduction about the coverages system, simulation of coverages area, and predicting antenna propagation. And we will invite all the participants and also the people that doesn't participate to join us to the next webinar. And personally, I thank all the participants so much for their attention, and they are free to pose us any kind of questions through the web, and we will be much more than happy to reply.
Okay. If you have any questions, please write them down and send them to us, which you should have some information in the invitation to this webinar, or you can certainly contact myself or Alberto.
Yeah, sure.
And if you want to talk to Alberto directly, you can contact him. I'll be happy to give you that information. So thank you again for coming, and this concludes our Itelco Elenos Group presentation for today.
Thanks for joining us. Bye-bye.
Bye-bye. Ciao.
Bye, thank you. Ciao.